Yes, I could fall asleep to my own videos. I could just set up a video next to my bed and I'd pass right out. All right, so here we go. So, since the first derivative is slope, the first derivative at -1, we found the slope between the two closest points to -1. Now in the next one, that point isn't even on the table. It's 2. So what 2 points are the closest to an x value of 2? 1 and 4. So we just find the slope between 1 and 4. So we take -33 minus a -25 over 4 minus 1. Okay, y2 minus y1 over x2 minus x1 is slope, plus a positive -8 over 3 is -2.67. Let's do one more. 4. Which two numbers would I use there? 3 and 5. 112 minus 95 over 5 minus 3 is 17, or the normal 17 over 2. 17 over 2 is 8.5. Okay. Since I have something highlighted, it's pretty gosh darn important. To be a differentiable function, it must be continuous, non-vertical, and it cannot come to a point. It must have the same limit from the left and right. That is very, 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 very important to know. To be a differentiable function, to have a derivative at a point, derivative, differentiable mean the same thing. Okay? To be differentiable means to have a derivative. It has to be continuous. It cannot be a vertical line because vertical lines do not have derivatives. And it cannot come to a point because when it comes to a point, it has a different derivative from the left and the right. Okay? So that is very, very important. So we're going to look at graphs when we do this. All right. So a line like this will have a derivative everywhere from -9 up to -3 with no problems because it's a smooth curve. Okay? The derivative as you're coming towards 7, -7 on this side and -7 on this side is basically about the same. The slope right here is basically about the same as a point 0.00000 to this side and 0.0000 to that side. Okay, they're about the same. Where you run into problems, and this isn't a huge great example, but it is an example. Look at this line. It's going up and then suddenly it becomes a straight line going down. There's a definite change in what's going on that graph. Okay? Over here, from 2 to 9, or probably 2 to 10. So if it goes 10 and down 1, the slope is like -1/10 here this whole time, all the way up to here. And this one has a positive slope. So if you go from positive slope as you're coming into 2 and a negative slope right after 2, right after 2, it's not a curve, it's a sharp point. Then right here, this point right here does not have a derivative. Okay, that point does not have a derivative. And an asymptote, where the function hits the asymptote, where there's an asymptote, there is no derivative there. Okay, so where is it not differentiable? Well, it's not differentiable at -2, and it's not differentiable at a +2. Those are the 2 points this one is not differentiable at. Okay, this one. Looking at the graph. Is there any point where it's not differentiable? The answer is yes, there is. Where would that be? Is it continuous the whole time? There's no holes in it, so yeah, it's continuous. Does it ever go vertical? And Henry's going, maybe. And yes, Henry, it does go vertical. Right there. It goes vertical. So since it goes vertical there, it doesn't have a derivative at -4. And that's the only thing wrong with this. 0 is fine. 3/2 is fine. 5 is fine. But -4 is not fine. This one. Is there any place where this is non-continuous? Yep. At 5, it's non-continuous. Is there any place where it's vertical? Yep. At 1, it's vertical. Is there any place where it comes to a point? No. I mean, this is close here, but there's enough of a curve here where I think we're fine. So it's just 1 and 5 in this case. All right. Then we get to continuous differentiable, and you have to understand the difference between continuous and differentiable. Continuous is the point works in both. It has to be the same point in both. Okay, so this point and this point has to work in both to be the same point. That's continuous. Differentiable it must have the same slope. From both sides at that point. Okay, they must have the same slope at that point from both sides. Okay, so do you know how to find, okay, let's look at continuous first on this one, and then we'll talk about differentiability. Continuous. If I put a 1 into this, what do I get? -5. If I put a 1 into this, a 1 here and a 1 here, I get 7 minus 12, which is -5. So it is continuous. So yes, it is continuous. So we know continuous. You know continuous. Okay, so it must be either A or C. Now we have to figure out if it's differentiable. Now, the only problem I have with them throwing this section here is we haven't found the shortcuts yet. We haven't done the shortcuts to find derivatives. That'll be next week. So I tell people, let's graph these. Okay, so you get out your graphing calculator. Oh, there. Sorry, I gotta just adjust a little bit to be there and there. Okay, graphing calculator on. Y equals, clear out what's in there. All right, my first y equals will be x squared minus 6. My second one is 7x squared minus 12x. Graph. And it looks, that looks really good. And then all of a sudden, a second graph appears and you're going, okay, what's going on here? So what happens here, let's go zoom, or actually, let's change our window. I want to zoom in right around what's going on right here. And when I put in a 1, I got a -5, right? So I want to zoom in right around -1, -5. So I'm going to go from 0 to 2 in my x value, and from like -8 to -4 for my y values. So I can see what's going on here. Okay? So as you're coming up through here, right here, it looks like, because you're going to trade graphs right there at 1. So at 1, you're going to trade graphs. Now, the graphing calculator is really nice because it'll find a derivative for you at a point. Okay, how does it do it? Well, you go second, trace, and then dy dx means take the derivative of y with respect to x. So it's number 6. So press the number 6. Okay, so we're on the first graph, y1 equals x squared minus 6. Do you see that at the top of your calculator? Okay, and I want to find the derivative at that point, 1, -5. So if I hit enter, I get a derivative of 2. Okay, 2. Now, then I'm going to do this again. Second calc 6. And it gives me the same thing up here. Now, if I press my up arrow, it switches graphs. I go to my other graph. I'm still at 1, -5, right? Now, if I want to find the derivative there, I press enter. And look at that. What do I get? 2. The derivative is the same in both. So it's both continuous and differentiable. Okay, we used our graphing calculator to say that 1, -5 is in both, and then they both have a derivative 2. And see how it's smooth from here to here? It looks like a smooth curve. Yeah, so it works for both. Let's look at this one. If we look at a 3 and we plug a 3 into here, because that's where we're looking at and that's where the graph changes. So if we put a 3, we get -9 plus 2. What's -9 plus 2? -7. So this is a point 3, -7 in this where it ends. And then if we put 3 into here, we get 9 minus 15, which is what? What's 9 minus 15? -6 minus 1 is -7. So this is 3, -7. So for both graphs, we get the same point. So it is continuous. All right. So let's graph these. And then I'm going to return to my normal window. To return to my normal window, it's zoom 6. And it returns to your normal window. So I'm going to go y equals, clear. So my first y equals will be -3x plus 2. My second one will be x squared minus 5x minus 1. So I'll graph those. One's going down like that. One's going like that at 3, -7. Now, if we look at 3, -7, we're right here. It's going down like this, and then it curves up like this. Does it look like it's going to be differentiable there? No, it doesn't. Okay? Because what happens is the slope of this one is going to be 1, and the slope of this one's going to be -3. Okay? So they're going to have different slopes. So it is continuous, but it is not differentiable. Okay? Now, looking at the graph, you can tell that because it comes to a point and then it changes slope right away. So you can tell that. Let's look at this one. Is it both continuous and differentiable? Let's figure out continuous. If you put in a -4 here, you get 16. Half of 16 is 8. So it's -4, 8. If you put in a -4 here, you get 16 minus 20. What's 16 minus 20? -4, right? Is this continuous? No, it's not going to be continuous. Can it be differentiable if it's not continuous? No. So, B here is never, ever, ever an answer. You can't be differentiable but not continuous. Never an answer. It's not continuous, and so it's not differentiable. So if it's not continuous, it cannot be differentiable. So it's neither. All right, last one. So if you put in a 2, you get 4. The negative of 4 is -4 plus 3 is -1. So this is 2, -1. If you put in a 2, you get 2. 2 squared is 2. 4 minus 5 is -1. So you get 2, -1. Okay, so those are the same. So let's graph those, because you guys as of yet, don't know how to take the derivative of that. So you go y equals, clear down, clear up, -x squared plus 3, and then parentheses x minus 4 parentheses squared. And I got an extra parenthesis, I know, in there, but that's fine. Minus 5. If I just close it out, same thing. All right. If I graph those two. At 2, -1. At 2, -1. I'm going to zoom in on that. At 2, -1, this is one curve coming down like this, and the other curve is going like this. So it looks like a pretty smooth curve there. So to check it, it's second trace, 6, and then we go to 2, because we want to be right at 2, and my derivative is -4. So f prime there is 2 is -4. Let's see what the derivative here is. So then we go second trace, 6, and then I got to make sure I jump lines so my y2 is up. I need to go to 2, and that is also -4. If they're the same, then they're both continuous and differentiable. Okay, so your assignments are out there. You'll have 3 little sections to do. Okay, that's all we're doing today. On Monday, we'll take a quiz and keep moving on.
Can we get a checklist for what we have to do with this stupid?
Yes.
We have to roll on the ground.
What?
Just smush the bean. I have to roll over it. I have to act like
Okay.
What do we have to do? Lay on his stomach and roll to our side? No, I think we lay on his back and roll to his side.
Okay, so go get your checklist,
Thank you.
and then I can point and laugh.